Welcome to another video. Today we are going to be going over the logic gates and what they do. Quickly, a logic gate is sorry. A logic gate is a system in which it takes an input or inputs and outputs a specific thing. It outputs something based on what it does. So, if I can grab these really quick, because they were supposed to be here but they messed up. This is why I don't really like the copying thing, because if you look here, you could have seen that it was on even though it was technically powered off. That's just because it does that sometimes when you move it. When you save it and place it, it doesn't do that. So that is a really good thing to know in case anyone needs to figure out a problem on why that's happening. So first we have our NOT gate, which is actually a component. It's the NOT gate / inverter right here. And if you look here, you can see what it does. When this thing is input, when the input is on or on, input is on or 1, the output is off or 0. So, and when it's off or 0, it's on or 1. So it just does the opposite of what's going in. This is our delay, one-way, either of those. It just allows it to go one way and stops it. In this case, it doesn't delay. Your actual delay would be this, but this isn't a one-way. So if you wanted to make a delay / one-way actually, you'd have to combine them. Something like this. If you do that, it now delays. Some circuits need this, like I made tic-tac-toe and this required it. Next we have our OR gate and our NOR gate. The OR gate, we can line these up to show what the difference is between them. So if I just link these, and I link these, so now the inputs are the same for both of them. Now you can see that, no. You can see that, that's why I don't like moving them. Now you can see that they're both different. No matter what, they're always going to be the opposite of each other. So the OR gate, as long as one signal is on, the output is on. But the NOR gate, only when both are off is it on. So when they're both 0, it's 1. When one of them is 1, it's 0, and when they're both on, it's 0. But this one is the exact opposite. So when they're both off, it's 0. On is 1 on equals 1, and both on is still 1. Actually, hold on. You can make a NOT gate up to anything, so you can have it linked to as many different circuits as you want. If you wanted to do it like, this also works as a NOT gate. It's just way larger. Same thing for the NOR gate. You can combine as many signals as you want. That comes in handy when you're making certain things like a calculator tic-tac-toe, both of which I've built. Next we have our AND gate and our NAND gate. Now, I'm still going to move them, just because. I'm not going to be moving those things below it though. So these are, let's just make sure this actually turns off. It does not. I'm just gonna fix these really quick. Okay, there we go. So these are our AND gates and our NAND gates. The AND gate and the NAND gate. Again, the reason this is a delay or a one-way, and in this case I'll just say one-way. The reason it's a one-way is because two XOR gates, two NOT gates can link together to make the same output, because you see the input is off and the output is still off. So you have your two inputs for an AND gate, and only when both are on does the output turn on. In any other case, it's off. But with this one, in every case except when they're both powered, it's off. just does the exact opposite of what a normal AND gate would do, or a normal AND gate would do. And then finally, most confusing one, which this is usually the system I do, is an XOR gate. What it does is only when they're both off, it's off, and when they're both on, it's off. Only when one of them is on, is it on. This is the exact opposite of that, in which only when they're the same is it on. You can say they're kind of a comparator to tell you if the numbers are different or the same. Because if you had, say, a bunch of these ones stacked up on top of each other, had them link it to an AND gate, I'll show that at the end of the video. So only when they're different does this change. But when they're both on, it's still off. When these are both on, it's on. But only when they're different, it's off. So now what you can do is, if you wanted to, say, check to see if the number was the same, you can just copy it, paste it a few times, and then what you can do is say that since these are the same number, oh, these are wrong. Okay. So if you want, you say this is 1, this is 0, this is 2, 1, 2. Oh, hold on. 2, 1, 2, 1, 2. So this would be a 3-bit number, and if you run all of these outputs into an AND gate, which in this case would actually just be, again, invert it, since the output of this and the input of the AND gate is the exact same. You can just make it link up like this, have it output as a number like this, link these XOR gates together, or in this case the XNOR gates, and now that's fixed. It will tell you when the numbers are equal. So if the numbers are ever different, then it won't be outputting. If the numbers are the same, say this one and this one, it will output. And something you have to learn with bits is that if you have two numbers, if you have this number here, and you have this number here, actually, this number here, it's more likely, instead of these matching together or these matching together, it's actually these bits matching together. So that's why it's like this. These two bits would match to here. These two bits would match to here. And these two bits would match to here. Oh, I somehow just duplicated it. These would match to here. So the top would be on, bottom would be off, etc. That was a ghost block you saw there, and you just need to delete that. Those shouldn't exist. But when both numbers are equal, it would output the same thing. Most often, you're going to be using the OR gate or the XOR gate. The AND gate is pretty useful in multiplication systems, but it's not really much. And yeah, just most of the time, you're going to need to have the XOR. You just have to have all of the gates memorized. In really any case, you have to have all of them memorized. So, thanks for watching, everyone. I hope you enjoyed the video, no matter how many times I messed up. And yeah, that about does it. Thanks for watching. I hope you had a great day.